So good afternoon, everybody. Thank you so much for coming for this lunch hour session. My name is Latson. I'm a senior architect for our professional services division for AWS. This is literally a fourth continent that I live and work on, and which kind of explains my accent to a degree. I'll be talking to you about simplifying Microsoft architectures with AWS services. So, what can you expect from the session? So being a level 200 session, I'm going to focus on explaining the simplicity and automation of deploying workloads in AWS, specifically Microsoft workloads. Also, the best practices and common architectures and patterns that are followed. We'll look at, start off with the identity management aspect to SQL Server, developer story, and administrator story. And at the very end of the presentation, I do have a little bit of a surprise for you guys, but you will find out as we get there. So, what do we use Microsoft workloads generally for? What do we use it on AWS? First and foremost, it's the corporate applications. These are your internal applications. These are your Exchange servers, your SharePoint servers, your Skype for Business, your Dynamics AX, CRM, and so on. Then there's a number of line of business applications, be that the ERP applications or the that are effectively specific to your business, or .NET applications and custom applications that have been built. There's also end-user computing, everything from the workstations and deployment of the same, configuration management of the same, and of course the developer platform and tools, which we're going to cover. So this is a brief overview of the type of services that we have and that we use for these particular categories, such as business applications, corporate applications, end user. And you can see the underlying services that underpin and support these type of workloads, DevOps and infrastructure beneath it. However, security and information security is over-encompassing aspect that encompasses both the DevOps and infrastructure, as well as all the different types of applications that we're going to be running on top of it. So, let's start with architecture. So this is the kind of common type of architecture you're going to find when it comes to like initial first deployments of Microsoft workloads in AWS. This is the type of architecture that you will commonly see. If a customer, let's say, is just deploying a single workload in there, trying to test, kick the tires or use a test environment or QA. If you actually go ahead and search for AWS Quick Start, you will actually find a CloudFormation easy deployment of architectures like this for Exchange, for SharePoint, for Link or Skype for Business, and few others. And they kind of follow this principle and a pattern when it comes to deployment. You're more than welcome to go ahead and kick the tires on it, see how it works, see what the performance is, run it as your POC, and find out what the what the performance measurements are, what the capacity expectations can be, and so on. So typically, what you have the public and private subnet. And as you can see, they're all encompassed within a VPC, which is a virtual private cloud. The individual subnets, you can see we have one for each availability zone to provide the availability between those. And that also provides effectively sufficient availability for most DR scenarios as well, specifically for Microsoft workloads, as well as Linux type workloads. So what we keep traditionally in the public subnet, we have a remote desktop gateway, And then we have the net gateway or the net servers that are doing network translation for the internal servers to pull updates when they need, should they need it. And then the private subnet is not exposed to internet in any way. And the remote desktop gateway is being used by remote users to access as well as administrators. Here we go. Using elastic load balancer, but also internally by deploying, oops, I went a little bit too far. By either connecting via VPN or AWS Direct Connect. You can also access the same applications or with internal zones via internal elastic load balancer. You would usually, there's another aspect, you can have a protected subnet, which is more like it doesn't even have any routing to the VPC net gateways for any pulling of the data from the outside. One thing that I'm going to now cover in more detail is each of these aspects. Besides the actual deployment of the network infrastructure, identification, but we'll start soon with the actual directory services. In this case, I have AWS directory service, which can be used. We have Microsoft AD as part of it, or you can actually drop DC servers in the same way in this particular architecture. So once again, it seems to be skipping. So this is what I talked about. You can have RDP over HTTPS access to administer your entire architecture if you're coming from the outside, and where the remote desktop gateway servers effectively sit there as your bastion servers. If you're administering it remotely, if you're coming from the inside, you obviously would be coming directly via VPN or Direct Connect. So, what's one of the really important aspects around building out and moving all of your workloads, Microsoft workloads specifically, into a cloud platform such as AWS? They're not, you usually have these supporting services that the rest of the other services or workloads that you're deploying, whether they be enterprise applications, B2B applications, whether there's be custom applications and so on, depend on. So usually you'll have at the center of it, you'll have Active Directory. Everything needs an Active Directory. You'll have possibly a system center deployment, which would be your SCOM or SCCM, whether it's used for monitoring or configuration management. And in a lot of the cases, also the SQL Server farm seems to be something that the DBAs like to consolidate in a central location and then provide that as a service to all the other applications as they need it. So that wasn't reflected in the previous pattern, but the common pattern used when it comes to these type of applications and a multi-VPC deployment is effectively using a shared service VPC. And as you can see, it's usually when you're planning, which in a lot of our cases has been, from the lessons of the, from the trenches and professional services engagements that I've done, a lot of our customers moving all out into AWS. So this is a good pattern for moving all out and moving most of the architecture over there. Then also when you need to have your replicated services, such as Active Directory or proxies that you need to run in there. And this is a great pattern for many reasons. First of all, because that's necessary for a lot of Microsoft workloads. As you probably know, enterprise workloads themselves are fairly chatty. They need to be close to AD, to DC servers. Also, it allows for these resources to be centrally shared, and also it offloads a lot of traffic that would be going via your VPN or direct connect connection between, let's say, your data center and AWS. You can also use it to limit VPN and control VPN traffic as it's coming through. And it allows you also to build out very strong security and compliance programs. You are able to actually implement a lot of ways of securing communication, of controlling what type of communication goes through and how that kind of gets distributed to what workloads and so on. So, you're probably asking yourself, this is great. Okay, so now I know what my base deployment is. Something I know how to kick the tires in, something I know how to deploy individual applications. Now I know how to start actually migrating my entire infrastructure into AWS. How do I do it? We do have several tools, and I will touch on some of those for deployment and for continuous deployment and CDCI and also for configuration management and so on. But at the base of it all, from a DevOps perspective and what's our infrastructure as a code is CloudFormation. Some of you already know what this is. For those of you that don't know, it's a JSON formatted document that describes the configuration of how everything is going to be deployed. The JSON is there mostly because there's also a lot of different frameworks like Troposphere and different tools like Terraformer and so on that allow you to actually build out the CloudFormation templates. There's also kind of already pre-provisioned tasks on a lot of CDCR platforms such as Jenkins and so on that directly support creation of the CloudFormation itself. The deployment of CloudFormation effectively is referred to as a stack. For the most part, you would actually break up separate stacks. You'll see, for example, in the AWS Quick Start that I mentioned earlier, that it's a multi-stack deployment. And you'll see that we break out the stack, first of all, for AD as a separate one, the SQL as a separate one, then the application as the last one. The reason for that is that if there's something happens during the deployment of any of these individual ones, it doesn't actually roll back the entire thing. So that you are able to effectively deploy infrastructure in layers, data services in layers, and application and web services in the same layers, and have full control over it. And having a master CloudFormation that kind of controls and defines in which order these things get deployed. It is a fairly easy language to comprehend. You can use literally, most of us use any kind of type of text editor. Visual Studio also has templates for actually creating CloudFormation templates, I basically use Sublime, and you can use Atom or anything like that. It's magic, like you wouldn't believe, of a sort where you effectively, besides repeatable resources that you might already have and that we provide for you through the Quick Start guides, you can effectively build out your entire infrastructure in next to no time. As you can see, the whole workflow as it goes, you will save it locally on S3 bucket, then AWS CloudFormation would create a stack, and then the CloudFormation service would start constructing your entire environment. We also have a CloudFormation designer for those specific, CloudFormations on the Quick Start guides that I mentioned. You can go ahead and plug it in, and it will actually create a Visio type diagram that shows you what type of infrastructure it's about to create in a visual manner. Other things that we have, in addition to the services that I'm going to be discussing now, that help you put and create infrastructures as well as migrate your existing infrastructures into AWS. We do have a number of what I refer to as the work services. We have Workspaces, which is actually virtual desktops and allows you to create thousands of virtual desktops for your remote users as well as your internal users and so on. We have customers that are literally using it in thousands. It's extremely popular We do have several options on the type of instance types and kind of default OS that is being used. But if you prefer something like Windows 10 and stuff, you can actually create a Windows 10 image and import it, and that can be used for remote desktop aspects. I strongly encourage you to use it. It's something that I use every day. We also have Workspaces Application Manager, which is there to actually manage the configuration aspects of workspaces that you've deployed. So that would be deployment of all of your applications, everything from Office to other applications, to decommissioning of those applications, running update on the applications on your desktop, as well as packaging a virtualized environment for your applications to run on workspaces. WorkDocs. WorkDocs is basically our document sharing, file sharing solution, similar to the likes of OneDrive, Google Drive, Dropbox, and so on. It allows you to collaborate, share in a secure way, and work on documents together in teams. And what's great about it is that it's built upon the S3 or Secure Store Service that provides you with 11 nines of durability, and it's extremely strong, easy-to-use solution with amazing infrastructure behind it. And then there's Workmail as well. So we provide an alternative to a managed service for mail. If you wish for us to manage mail for you and all that, you can effectively use Workmail instead of, let's say, Exchange and so on, in addition to the rest of the services. Of course, the directory service. Mentioned we had a workshop early on today, talked about all the aspects of AWS directory services. You do have an AD connector, which is more of just a proxy for your Active Directory in AWS. Those are more like for lighter or fewer workloads if you're running. But we do also have Microsoft AD, a full-blown Microsoft AD that now even supports schema extensions and everything. There's a fully managed solution that is fully available, and we can take care of it, and effectively you can extend your directory there or run your entire Active Directory. We have several customers that are running their directory from AWS via AWS Directory Services. And more importantly, this was a very recent announcement. Right now, you can run Windows Server 2016 on Amazon EC2. What does that mean? Besides running Windows Server 2016 data center with your desktop's experience and all the great and new features that have come with it, you can also run Windows Server 2016 Nano Server. You can migrate all of your applications to your Nano Server, and there are several articles on how to do that, and we can share that through our blog post. There's also Windows Server 2016 with containers, where you can effectively run Docker containers on top of Windows Server 2016. So all you really have to do, start a Windows Server 2016 instance and run this particular command, docker run Microsoft sample.net, and it will actually run a sample Docker container for you. You can see how it runs. You can kick the tires and play with it. And more importantly, we do also have an offer Windows Server 2016 with SQL Server 2016 now, and all the great new features that 2016 has got to offer. And I will cover some of those as we go again. So let's start with the first and foremost thing that you probably need. What do you need? What is the first thing that most of us need when we start migrating Microsoft workloads specifically into AWS? And what makes it different from all the open source and Linux ones? The first need and the first thing is in the identity and access management, right? Basically, the first aspect is authorization and authentication from a Windows perspective, specifically for the Windows workloads. But where does that story start? It starts with our IAM service, AWS Identity and Access Management. which basically provides you with role-based access control to managing all of your resources and services in AWS account. We provide you with multi-factor authentication, and it's integrated, obviously, with all the AWS services. The role-based being the key here, okay? For the most part, first thing when I come to some of the customers, they go, you know, can you go ahead and create a whole bunch of IAM users for us so we can start using it? This is not what we recommend, because for the most part, for Microsoft shops and sites and customers that are actually using Active Directory, they control Active Directory and services specifically, you know, centrally from the Active Directory, whether the Active Directory is running on-premise or in AWS. They want to kind of consolidate all of the security and all of the users and everything there. So I'll discuss shortly now, effectively, delegation using federating identities from Active Directory by ADFS to our STS and to our IAM service. Then they would take on one of the roles over here, and those roles will have security policies that are attached to it, which kind of spell out what the user is allowed to do and what they're not allowed to do. So, common approaches to extending effectively your identity management, you know, into AWS is using AWS directory services, using federation to AWS services to your Microsoft workloads, using claims-based access or SSO, using federation clients such as ADFS, Ping Federate, or Okta. And there are many others, or using Kerberos to actually delegate your authority there. One of the things while I'm on Kerberos and the whole thing is that, you know, what I showed you earlier was using the Elastic Load Balancer, which is our service, which kind of simplifies it where you don't need to effectively use any appliances or, God forbid, hardware. But you use a solid, scalable service like ELB. ELB does not support NTLM, being kind of somewhat archaic way of authenticating. It does support, which is more secure and obviously faster and better, either using claims authentication or using Kerberos. So back to the actual identity management. One of the most common approaches, you can just extend your single domain to multiple sites. Just drop another, you know, 2 DCs over in AWS in each availability zone, and just directly extend your Active Directory there. Or you can have a one subdomain per site. If you have multiple sites and you want to manage them by subdomains, you would effectively, this would be, let's say, you know, cloud.company.local versus cloud.local that you have running on your on-premise side of things. Or you can have one forest per site and a trust relationship that is established from your on-premise to the Active Directory the redundant one that you've deployed in AWS. You can have 1 or 2-way trust established, depending on your need. You can also use AWS Directory Services, specifically Microsoft AD, for this. So how does the federation work? You have, and this is what I explained earlier, you have your Active Directory, which is kind of on top. You have AWS IAM service that I talked about earlier. You have AD users over there, and they need to assume roles and access the services for administration or provisioning. So federating via ADFS would allow you to, to assume those identities and assume those roles and have access, appropriate access to, and secure access to the services. Also, here we go. Also, you can have isolated domains. It seems my clicker is skipping. You can have isolated domains then you can establish, and this is kind of a common federation scenario for a lot of those cloud services. Those of you that have been working with cloud in the past and various different cloud platforms, this was one of the common patterns and so on, where you can establish federation. You would have your ADFS proxies, and you establish federation as well as the synchronization to the Active Directory deployed on the AWS side, and then you would basically be accessing it via those federated identities. Hello, clicker. You can also use, obviously, the same with AWS directory services, specifically with Microsoft AD. So ADFS scenarios. For those of you that have worked with Active Directory Federation services, these will probably be familiar to you. You can have a fully implemented ADFS, which basically has core authentication services exposed to the internet by ADFS proxy, which is the scenario that I just introduced right now. That is possibly the best one. Why that one works? Because you might be federating to some other internet services out there and some other SaaS services from different providers and so on, and you can use it in the same way without having to redeploy a separate set of ADFS servers. You can have a firewall published ADFS. Firewall exposes, that will be effectively a proxy that you've defined. And unfortunately, when you do that, there's certain security features that the enabled security control cannot be turned on an ADFS for that. So it would be effectively just doing reverse proxy configuration into your ADFS. As such, because of the less security, I don't really suggest doing those. And then you have the non-published ADFS and the VPN published ADFS. They're basically the same in a sense that VPN published one is probably more relevant to deployment in AWS, where you would have federation going across the VPN. Most likely not really applicable in most cases with us, but if you happen to be running, the only problem really with that is that your ADFS proxies are not exposed to the internet, and as such, you can't really extend federation to any other system that you may be using or any other internet service. So what does the Active Directory Federation Services deployment look like? Pretty much something like this. You would have your ADFS proxies up in the public subnet and the ADFS servers running internally with DC servers behind that, and you would have established federation, synchronization back, and as such, you can also have that kind of also deployed to federate to any other systems, to any other sites, and to any other services if you're running it straight out of AWS specifically. You can also replace that with AWS directory services, specifically the DC servers on the bottom, and use that together with your deployed ADFS and ADFS proxies in there. So what this is, pretty much from an overview perspective, we have covered the actual identity management and extending and federating into AWS specifically for Microsoft workloads. The SQL Server, there are several licensing options. You can purchase an Amazon instance that includes Windows and SQL, like what I showed you with Windows 2016, with SQL 2016. We do have different versions as well and different AMIs you can use. Or you can purchase your Windows AMI and install SQL Server yourself, but bring your own license. Both authentication methods are being supported, and you can have full control over it. You can run any type of high availability and DR scenario on SQL, the most common one being the always-on availability groups, which is actually an evolution of log shipping, and kind of a third generation after mirroring and so on. Or you could be running failover cluster instances. The main difference with the failover cluster instances is, so this would be basically your common always-on availability group with synchronous commit. Separate things. You always-on availability group for SQL 2012 allows synchronous commit between 2 instances and 4 asynchronous commit instances. And 2014 supports 2 instances for synchronous and 8 for asynchronous. And those can be also read replicas. And you can use them for reporting, or you can use them to run analytics on it, and so on. And 2016 allows actually 3 synchronous commit servers, with 3 in total, and many more asynchronous replicas that are going to be running. So this is a very common scenario, very common deployment that we have for most of our customers. You can also have a multi-region always-on availability group. As you can see, I have 2 AWS regions. I will actually be talking about specifically this and showing you a demo of it on Thursday at 1 o'clock. It's a WIN403 session. So I encourage you to come and see it. So you can effectively run synchronous commit between 2 availability zones and have your DR side running, let's say, in AWS in a different region, or it can be on-premise with asynchronous commit over there. So now this is permitting the latency. I would say, I would encourage you to test it, but you can actually run even synchronous commit, between 2 regions in US. Provided that you have AWS Direct Connect, you can also you should be able to kind of test out some synchronous commit scenarios. But for the most part, this is the common pattern and the common implementation that we do and see. So next up, these are the failover cluster instances. The difference with those is you would have multiple nodes, and that actually allows you the failover on the node side of things, whereas the actual storage is shared between multiple nodes. So it doesn't really provide you with data redundancy, where the always-on availability groups do, and mirroring before them and so on. We do, however, have third-party partners, ISVs like Softness and Sios that provide very amazing solutions effectively for providing shared storage specifically for running SQL in that way. I would encourage you to look those up. And they have a way of using either EBS or S3 specifically for that, which is amazing. We also have Amazon RDS. We do have several databases, but more importantly, I want to focus on SQL Server. We do run SQL Server. We allow you to run up to 30 databases. We allow windows of mixed authentication. We have optional managed multi-AZ deployment as well, so you can actually run it in multiple availability zones, and you can define how many and what. For compliance reasons, we have encryption at rest with transparent data encryption, and we allow you to use SSL to secure data in transit. We do have native backup and restore. We use that for backups, and you can define those backups specifically when deploying and running SQL. SQL in RDS specifically uses actually our own special version of mirroring to provide high availability across multiple zones. It has automatic failover, automatic host replacement, backups, and software patching. You can actually switch that off if you want to, but that's what we provide as part of our service. It pretty much looks the same like what I showed you earlier, but this is a managed service, and as such, we do not provide you with an OS level access there. Because of that, that doesn't make it suitable for a lot of enterprise enterprise workload scenarios, specifically on the Microsoft side. So anything that has extensive use of store procedures. As you know, store procedures have file system level access, and as such, because we don't allow that from a managed service perspective, we won't let applications or enterprise applications such as SharePoint, such as Exchange, such as Link or Skype for Business, they won't be able to use the service. But your .NET applications that might use more simpler scenarios would be great for our managed RDS service, right? If you happen to now run SQL Server as part of our managed service, as part of AWS RDS offering, we do not provide integration services, reporting, and analysis services, such as also like SQL Agent, Service Broker, Master Data Services, and all that. However, you can run those on EC2, and you can connect it to the same way to the actual managed service on that other side. So, to kind of wrap that up on why you would use it is really if you don't want to manage SQL Server, or if it's for some specific workloads that your DBS don't want to manage, you want to leave it to our DBS to manage, that is a great solution. But bear in mind the level of support and for what type of applications you can use it. Developers. Okay, so hopefully we have some developers over here. We have our guys have done tremendous work on this side. I used to work with, on the other side with the Visual Studio team in the past and all that. And I must say, we have some incredibly smart people that have done tremendous work in integrating AWS with Visual Studio. So we provide you with also AWS tools for Windows PowerShell, integration into Visual Studio, ASP.NET session provider that you can use, trace listeners, and so on. We provide you with all the utility APIs that you can access, service clients and support, all the way up to ASP.NET 5 as well as .NET Core, right? What does it look like? It looks like this. It's fully integrated. You can swap between regions, and you can access and create your resources in the services, and you can also edit those and use them like you would in a console. But more importantly, you have so many different, you'll see the AWS kind of branch of all the different projects you can create. You can create for every service that we got out there, simple notification service, simple queuing service for decoupling of your systems, and even things like Kinesis and so on. There's different console projects, as you can see, and you can create web applications that you can just directly publish to AWS. And like I earlier said, also you can create things like CloudFormation templates and so on. There's tremendous work that has been done in integrating Visual Studio, more than I've seen so with integration for any other platform out there. So, for developers out there, I really implore you to take a look at those. Other things that developers can look forward to, there's an integration directly with Elastic Beanstalk, which is our deployment DevOps service that allows you to deploy your solutions, updates, and services directly to EC2. You can deploy it with automatic log rotation to S3. We also have several other services that you can use in the same context. We offer code commit, which is effectively our Git that you can use, code deploy, which is kind of a more detailed way of deploying solutions and updates to the servers, an alternative to Elastic Beanstalk, and more. I would say, like, you have a lot more control over how you want to deploy it, the way you want to deploy it to multiple servers specifically, things like rolling updates and so on, and access to any errors during the deployment specifically of your packages, let's say if something happened on specific servers and all that. So it gives you this insight, as well as the version control so that you can roll back earlier deployment in case something went wrong. And there's Code Pipeline on top of all that. And Code Pipeline is amazing because it provides a workflow for the entire DevOps pipeline, from code commit, code deploy, and other services like Jenkins and so on, all the way from development to test to QA to production. There's .NET SDK, PowerShell integration that I mentioned, and native integration also into other non-Visual Studio IDEs that you can use. Administration. This is pretty cool, pretty amazing stuff. A lot of people that go firsthand and deploy solutions, specifically Microsoft solutions in our environment, they're like, okay, we want to run we want to use PowerShell to actually manage not just our workloads, but also AWS services. We offer that. But on top of that, we have something called an SSM Server and EC2 run commands. And what an SSM Server is, it's basically a free service that we offer to everybody. It's a configuration management server that works like a desired state configuration, and it uses what we call documents, and EC2 run commands, which could be used to configure, update, patch, and do any remote administration automatically, and maintain the state of each of your Windows servers automatically. It can automatically put your Windows servers on your domain. It can automatically patch them. It can do any type of configuration management task, whether you define it yourself, and we do provide you with several of those, like join domain, update, look for latest updates, and run a full asset list of all the things that you're running on your Windows server specifically. This was very much built for running Windows workloads, and this is, in addition to everything else, proof of all the love we have and support we have for Microsoft and Microsoft workloads. These are the examples of the SSM commands. Run commands with SSM. As you can see, these are all the Windows one specific, listing Windows inventory, update config, run PowerShell script, configure Windows Update, install applications, and so on and so on. You'll specify your MSA package and all that. And then in case somebody changes something on any of the servers, the SSM server will make sure that that change is rolled back, and it will re-update or repatch that specific server. Monitoring. Last but not least, before I have this little surprise for you guys, the main services that we have for monitoring are CloudWatch, CloudTrail. CloudWatch provides instance level monitoring, but it doesn't provide application level monitoring. For those you can actually write those logs directly to CloudWatch, and that's fairly easy to do. There's also a number of different third-party monitoring applications that do that for you, and they write to their own service, such as Datadog, such as App Dynamics, and so on. The great solutions. I encourage you to look at those. CloudTrail is your service that actually provides an entire inventory of everything that you're running in AWS and tracking. It also allows, I mixed it up. Config is the service that provides the entire inventory of everything that you're running, and you can also write policies like governance around what each account or each VPC needs to have and all that. So you can enforce those policies, or you can report on those policies, back to your ops team. You can also provide a level of automation with Lambda, for example, with serverless applications like that. Like if, let's say, if resources are not tagged, and I really strongly suggest you tag all of your resources, that tags are either automated or they're enforced. And in some cases, I've built solutions where, on top of config, that go ahead and if people don't respond to tagging, for example, and to these kind of governance tasks, to destroy those resources, and that way force people to use AWS properly and to use your environment the way you intended it to be used, right? And then CloudTrail is really kind of, it logs every single API call. So even whether you're doing it from a console, whether you're doing it from Visual Studio, whether you're doing it from a PowerShell, all of these are effectively, in the end, API calls that are made to the services. And as such, it provides an audit of everything that is being done. VPC flow logs, extremely important. These are the things where you actually can, you have logs that provide you with insight in all the traffic that is happening between your instances and what's hitting them or not. And that you can use to automate any actions for possible attacks or intrusion detection or anything like that. From a security perspective, those things are amazing. There's also Trusted Advisor. Trusted Advisor, you need to look at. It actually goes ahead and lists out, all the things, all the best practices. It flags any resources that you didn't deploy or secure properly, and anything that where you might be wasting too much money and bringing up excessive cost, and provides you with solutions and suggestions on how to provide. But without further ado, I will go ahead and introduce Bill Roth. He's a VP of Enterprise Systems from Hess Corp, and he's got a great customer story. So I told you something about running AWS, running Microsoft workloads in AWS. He will, let's hear it for somebody who's had a lot of experience doing so.
Zlatan, thank you. As he mentioned, my name is Bill Roth, and I'm Vice President of Enterprise Systems for Hess Corporation. If you're not familiar with Hess, we are a global oil and gas company based in Houston. Currently, we're in the business of exploring for and producing hydrocarbons offshore and onshore here in the US and around the world. Our AWS story actually started back in 2013 when Hess was a very different company. At the time, we were what's known as an integrated oil and gas company with not only exploration and production business, but refining, marketing, and retail. Anyone who lives on the East Coast might be familiar with our Hess branded gas stations. And back in 2013, we sold off that business. At the time, when you carved out a business of our size and sold off a major division, the state of the art was to go out and procure tons of hardware, build massive redundancy of your environment, get it ready for the buyer, and then turn it over and give them not only the business, but also give them a very elongated agreement where they could run on your hardware for, in some cases, many years. We decided in 2013 to try something different and to move the carved out businesses to AWS. So at the time, we sold 6 different businesses, some of them with as many as 170 applications, and we're able to move them to AWS in less than 9 months. The tradition of having to build the infrastructure and run it yourself for a long time just didn't make any sense to me at the time, and we felt that there was a better way to do that. So some facts. We moved all kinds of Windows workloads. We were one big integrated oil and gas company back at the time. We had a single exchange environment. We had one massive SharePoint farm. We were across multiple data centers. We ran hundreds and hundreds of applications, SharePoint, Documentum, SAP, Hyperion, Dynamics, Salesforce, hundreds of custom .NET applications, you name it, we ran it. And our job was to kind of carve out each of those and move what we could to the AWS environment. So 3 phases. The first phase of the divestiture, we moved 170 applications. It took us 6 months. And at the time, Amazon didn't have all the frameworks and quick start guides and all the other tools that Zlatan's talked about now. So we kind of figured that out as we went. but still, to be able to move 170 applications over 6 months was pretty incredible. But we got better. And the second divestiture was 90 applications. We were able to do that in 3 months. The more telling stat that's not on here, when we carved out the first bit of business, 170 applications for our marketing business, my bill at Amazon was $500,000 a month. And we didn't care. We were giving it to the buyer. So anytime we couldn't fix a problem, we just bought more disk, and we bought more servers, and we made things faster, and we bought more redundancy. But then when I carved out the second part of business, the knowledge that we gained and the maturity that we gained around how to optimize our Windows workloads, yes, it was a smaller carve-out, but our bill at the end of the second divestiture was $50,000 a month. So we moved about half as many applications, but cut the bill by about 90%. Now, I will say that Jeff Bezos and the team helped us with some massive price cuts along the way, but a lot of it was just getting smarter about how to optimize our workloads as we got ready to carve them out. So now that we've done that within the businesses that we've sold, now we're moving it to our core business. So my team is currently in the business of moving as much of our Windows estate as we can to the AWS cloud. We've got integrating networking with Direct Connect, everything that Zlatan's talked about so far, using ADFS with EC2, using AD on-prem. We've done all that, and it works really, really well. You'll see in the top of the slide just some examples of the kind of applications we moved: HANA, Documentum, Oracle Hyperion. So just a couple things I want to share with you about my experience having done this for 3 years. I've not yet met a workload that can't go to Amazon. Some are harder than others. Some have tight integration. Some are real chatty. Some are poorly written. Some need a lot of disks. Some need a faster network. Some need some work by your developers who maybe got a little lazy when they built it. But at the end of the day, with enough energy and passion, we've found that we were able to move every single targeted workload to Amazon. But it's not always just lift it and shift it. A lot of times it takes tuning. A lot of times it takes re-architecting. But so far, my team has not yet met an application that won't go, and won't go well and perform as well, if not better, than it did on-prem. There were a lot of detractors when we started our journey. We find that our infrastructure team is generally the last to get on board with the journey. Developers get excited. They learn new tools. Infrastructure guys get scared. That's just the way our experience has been. Maybe it's different in other people's shops. But with a lot of support and a lot of training and a lot of guidance and a lot of senior leadership support, so far we have a lot more. Nowadays we have a lot more supporters than detractors, and that's a major shift from 18 months ago. The most important thing that I want to share, as Zlatan shares all these really cool tools and technologies that Amazon is coming out with literally every week and every month, this is a significant maturity curve for our company. Every day we're looking for ways to optimize and automate. And a simple example of that is when we go live with a typical workload, the developers and the users will say it has to be on 24/7 for dev, test, and prod. And then we kind of chuckle at that, and we push back and ask for a window. Just give me 2 or 3 hours in the evening, I can shut your dev environment off. And invariably, they give in on that, and then we push it further. And then we get to on-demand firing up of dev and test. And now we're moving toward fully encapsulated code that instantiates dev and test on demand, and we actually have no dev and test environments. I mean, that's the typical maturity I find of environments like this. Production's a little bit different. You need to have it on all the time, and thankfully, Amazon has great tools for high availability and disaster recovery and management that Zlatan talked about. But we find a lot of value in being able to change the model around how we run dev and test. Instances get right-sized every day. We found in our migration to AWS many instances of applications that were completely over-provisioned, some to the tune of 90 or 95%. And as we build out in Amazon, what we do is we build out for the smaller instance size, and then we scale up if we have to, as opposed to a traditional model, which says you over-provision because you don't want to have to go back and buy new hardware because it's just too hard to put that in. And as I said before, we're building our test and dev environments on demand. So overall, just wanted to share with you, I know it was brief and that's all the time they gave me, but I just wanted to share with you that as it relates to moving Windows workloads to Amazon, from a real customer experience, and our shop probably isn't that different from anyone else's Windows shop out there. If you had it, we had it, right? AD, Exchange, SharePoint, Link, file management systems, document management systems, information management systems, custom applications, off-the-shelf applications. We have it all. Most big shops have it all. And what we've seen is that with a little bit of work and a little bit of imagination, the tools available from Amazon will let you move all those workloads to the cloud without too much trouble and with a lot of real value at the back end. So just wanted to share that. Thank you for your time.